Alright, guys, so I'm gonna make this quick video on relating optics to optometry because for me, I think whenever I'm learning something, I'm always wondering like, why am I using this? Am I ever gonna use it again? And when I do figure that out, it motivates me to like learn it. So hopefully, Um, this will help you guys and motivate you if you're feeling unmotivated. So this also helps me because as for me, I'm a myope, a pretty high myope. So understanding how that works and how my glasses works really helps me understand optics a little better. So just to show you guys this picture, and maybe some of you guys know this already, but not everyone does, I think. So if you do, that's great. You're going to be seeing this again in visual optics with Stark next quarter, and uh, you're also going to be seeing this in clinical methods next quarter too. So, so if you look at this picture, this is like what we call a normal or emmetropic eye, where parallel light, like light from a distance, um, and it doesn't have to be like at infinity to call it for us to consider it like parallel. It could be pretty far away, maybe even like 50 feet or something. So parallel light, which has a divergence of 0, will come into the eye, and the eye acts as a overall plus system, right? So these rays, uh, which can kind of be considered a real object in a way because it's on the left side, they get converged onto, right? The rays are parallel, the plus lens converges it right onto the retina. So this is well, I'll draw it straight just to say this is the retina, right? So you want the image to fall on the retina so that the retinal cells can process the image properly and to your brain, and then you'll see what you see, a clear image. So if you're born with like 20/20 and you don't need glasses, this is pretty much you. Um, but for a lot of us like me and many people, we are myopes, which means we're kind of like, which is this bottom picture here. So that's when you have light coming in, but it falls short because the eye, it sort of acts like it's too strong, right? So I'll draw this arrow showing that the eye is too strong of a converging kind of system, so it converges the light early, right? And this little triangle shows that light still it's still continuing. These rays just continue on like this. This ray just continues on like that. And so the light stops early, and that's this picture right here. This is what we call the focal plane. So if you're a myope and you're ever wondering why is your prescription negative? Um, well, that's because when you use in this case, a overall concave lens, really, um, your glasses don't look like this. Usually for a myope, they look more like this. And you're going to see this in your manual um, as one of those lenses that you learned is called the concave meniscus. Um, yeah, the concave meniscus is overall minus, and this is the glasses we kind of use for a myope. So it looks like that. And that negates the eye because the eye is like two plus, it's too positive. So let's give it some minus and diverge those rays. I'm not gonna draw it because this picture does a good job. It diverges rays so that those rays can then converge um, kind of properly onto the retina. So hopefully you can see it. So now you have these two optical elements. This first optical element will diverge the rays, and then which causes like a virtual image, right? The image is kind of like right. Um, let's see. The image is over here, and then the virtual image, right? And so that virtual image then kind of becomes a real object for the eye. Uh, and so then that eye can produce a real image onto the retina. So that is why we use a minus lens if you're a myope, because your eye converges light too much. So that's me. I'm a -5, which means my eye converges too much by a power of +5. Uh, so yeah, and so for the hyperope, what happens with hyperopes is that the eye does not converge enough. So it's still converging, but if this is like the retina, and you want it to land here for a hyperope, then it'll just it'll be 2 converge way over here. So you're going to prescribe a hyperope another plus lens, right? Which looks more like the convex meniscus in your book, the convex meniscus, where this surface is not as curved. So it's overall plus, and what that will do is converge light even more, so that when that converged light comes in, it helps the eye converge it onto the retina, because again with the hyperope it didn't converge enough. So that's just my little quick bit on why optics is really important for the profession, why you're learning it. You'll use it all the time, and if you can think about this idea of a plus and a minus moving the image close to the retina or behind the retina, that will help a lot in terms of the concepts that you'll be learning later. And in terms of somebody who has a cylinder, right, or who needs astigmatism, right now I've been just talking about sphere corrections. But sometimes, because our cornea is not shaped properly, it has 2 different radii, right? It could look like this, and this is more curved than this one, right? So depending on the difference in curvature, right, it kind of looks like a football. Right, this is like the football, the football shape, rather than a sphere shape. So what happens is then the eye converges light, right? In a one line will be produced over here, and maybe the vertical line from the horizontal meridian is produced over here, and then maybe it's possible that in the other one, the horizontal line produced by the vertical meridian is over here. And so and then you have your circle of least confusion, right? For that kind of person with astigmatism, which I also have, you're using these lenses, whether it's a plus or a minus, to move that whole thing back and forth. Well, in a minus case, this would move it that way, right? Because it's diverging the rays, making them kind of land farther away. And so with a person with astigmatism, again, it's not, you don't want the vertical line or the horizontal line to be on the retina, but rather somewhere in the middle. You want the circle of least confusion on the middle. That's the best thing you can do for a someone who has astigmatism. Well, and I'm kind of simplifying this, but when you are correcting somebody with astigmatism, you're using lenses so that this line also moves this way, right? And so that this line moves this way, and so you have a combination of, wait, let me repeat that again. You have you want this line going this way, and you want this line going that way, so that you can have them both land on the retina. So hopefully that paints a clearer picture for this stuff that you're learning. Didn't want this to be too long, so yeah, if you have any questions about this stuff, let me know, and good luck with the rest of your studies.